So what are what's the best evidence for constructal law predicting design in nature?
Well, I everything I write is about those predictions. For example, why you predict. Obviously, this is the lessons that ducts ducts through which something flows should have a round cross section. That is the configuration that offers great access. Why at a so-called bifurcation, uh, if the fluid flow is slow, meaning laminar, there should be only two branches.
Mhm.
Why, if the flow is faster, like in a river, the average number of branches should be four. Um, by the way, a prediction that requires to be taken with a grain of salt because the river water flows on a terrain that's far from uniform, rocks and tree trunks and all sorts of also seismic faults. And but statistically, there should be four tributaries to a mother channel, and and also predict the shape of the snowflake. Predict. I'll tell you something. And you get into sorry, answers to questions people did not care to consider, such as if you drop droplets of ink on a piece of paper, whether the spot is a splat as opposed to a splash, uh,
Yes.
and when to predict it will be a splash and not a splat, uh, meaning the transition, the cliff between those two populations. By the same token, uh, I predicted from this constructor law the when the flow should be laminar and when it should be turbulent. In other words, turbulence, the phenomenon, is a manifestation of the constructor law, or of the tendency of what flows to reconfigure itself to have greater access. And what flows in most of these cases, these examples I gave you with the water, for example, or with the ink, is momentum, which means movement. Is not the liquid itself. It's actually the oomph, the oomph in the liquid that moves, the product of mass times speed. It is that hits you. When you feel the impact of the jet from the hose, is the momentum that pushes you, and
Mm.
it could move your head uh, out of your shoulders if that jet is like from the fire hose from a fire engine. Momentum, which is really a Latin word, you know, it came from Italian movimento. Um,
Mm.
it doesn't mean instant of time. It means motion. And from talking about now the French and the you say la langue québécoise, you mouvement is
Hmm.
movimento in French, mouvement, and that in English became momentum.
Okay.
Which of course confuses every student because they think that moment is supposed to be about an instant in time. Wrong,
Oh
wrong.
wow, okay.
Yeah, yeah,
Okay.
wrong. Very wrong. But you laugh if you're curious about the meaning of the words. Um, and yes, there are all these predictions, including important claims. I just made it that turbulence is because of the constructed law is no longer an unsolved problem. No longer. It's been solved for 30 years now, actually for 40 years, because I solved this problem even before I coined the Constructal Law. Before the Constructal Law, there were several of these ahas that in retrospect were prefigurations of the Constructal Law. Um, yeah, that's right. I'll give you an example. If you know, a prefiguration was to predict the uh, uh, the size and thickness of the hair strand on the back of every animal that has fur or hair. And the prediction is that the diameter of the hair strand should be proportional to the external length scale of the body of the animal raised to the power 1/2, meaning that the bigger animals should have thicker hair strands, but not proportionally thicker, a weaker proportionality. But the point is that the big, meaning that animal size matters. It is very important. But and then the design of the animal, because of these nonlinear relations, is the design of the animal is not a blow up of the design of a tiny animal. Uh,
Yes.
yes, but this was a puzzle in the biology, that animals are distinct. Well, I tell you, not only they should be distinct, but I can predict every drawing or every design if you tell me the size of that drawing. You see that? Uh,
Wow. Okay.
said the other way, Robert, like this. Um, if you show me the drawing, I'll tell you the size. In other
Okay.
words, yes, in other words, design, the picture means size. It's like you say, you have today a picture of a tank, a battle tank. That speaks of the size of that object, which you printed as this size. You see,
Right.
but if you show me one of these tank toys, you know, a toy on the same page, I'll tell you that thing is a lot smaller. Okay. Uh,
Even if they say like 1/64th ratio or whatever.
No, well, no. Then you're cheating. If they tell you, if they show you the drawing with a caption, that is no
Ah,
longer a drawing. Okay, that
okay.
is that is a page in a book called Know-how, and that's a very you wrote it in your bullets. Know-how is a very important word because that is what knowledge is. Uh, okay, if you want, so I compliment you on bringing it in your notes, because information by itself means nothing, but what you do with it, that's the know-how.
Yeah, because
That
you
is
said it knowledge is the ability to affect design change.
exactly. So that is knowledge, or in short, know-how, know-how. Um, but this is the beginning of a long series of jokes against our contemporaries. Some of them, some of them know a lot. Maybe they know too much because they read. But have they done anything with that? Nothing. You
Mm.
see. But there are some people, people who are not. They know that their place on earth is not to waste time. Who know just enough, but they are full of zip, and they take risks and do something with that secret, you see.
Hmm.
And here you have all the inventors, all the entrepreneurs, all the iconoclasts, all the way to Albert Einstein, by the way. He was one of these people who ran with the ball, you know, and he did it young. Uh, or Stephen Jobs. Everybody who, sorry, there are not many, but in that small, call it locker room, uh, the players happen to be of a very similar kind. Uh,
Yes, and you can. I think it's the Steve Jobs example is very good because he invented, the compute, like the app, like the Macintosh, and that was a design change to how we interact with computers. And now look at our society. We can't not operate with computers. And
Yeah,
within those
but
computers, there's I guess, the flow systems of software and applications that are now super robust. At least some of them are super robust, like Office Suite or
yeah,
whatever.
yeah, this is a great example for my generation and yours, but because Steve Jobs and his partner, there are two of them.
Wozniak.
Yes, yeah, but before that, there were lots of them in Andrew Carnegie. This is uh, steel making for what? For for elevating structures to unbelievable heights, through
Hmm.
steel reinforced concrete, and of course before that, there's iron bridges. They're actually made of steel. They're standing today. You go in places where railroads are still the main mode of transportation. You go to England, you see steel trusses everywhere, and they've been there since the 1800s. But before this, that steel is uh, should replace the brick, the fire brick. Uh, there were none of these structures. In fact, if they existed, they were made of stone and bricks, and they fell apart naturally, were under siege. Um, all these things. So the sparks of ingenuity or creativity uh, are uh, happening all the time, uh, and but they may be numerous, but the effects of those sparks are fewer because those endowed with a zip to do something with them are not many.